Hey there! Today's video is all about a tricky problem that some of you might have encountered while working with algorithms. The issue at hand involves a case where an algorithm designed to emulate a real-time clock in a non-real-time environment suddenly starts behaving erratically, specifically on Ubuntu 24.04 in WSL2 on Windows 11. The algorithm relies on predicting when the next time step should occur based on system clock time and repeatedly calls chronos now. However, in this particular setup, the now function occasionally jumps forward by a significant amount between successive calls, throwing off the entire timing of the application. This unexpected behavior hints at a potential bug where now is actually altering the system clock's time. When troubleshooting this issue, it's crucial to consider the nature of the clocks being used. The solution lies in switching from the system_clock to the steady_clock. While the system_clock represents the system-wide real-time wall clock, it could be adjusted at any moment, leading to the inconsistencies observed in this scenario. On the other hand, the steady_clock provides a monotonic and constant time progression, making it ideal for measuring intervals accurately. By making this simple switch in the code, you can avoid the clock-related discrepancies that have been causing trouble. In summary, if you're facing a similar problem with your algorithm altering the system clock's time unexpectedly, the key solution lies in using the steady_clock instead of the system_clock. By making this adjustment, you can ensure consistent and accurate timing in your application. Thanks for tuning in, and remember to subscribe, like, and leave a comment below with your thoughts or any similar experiences you've had. Stay curious and keep coding.